and welcome to my new video which is based on the classification of elements. So as you very well know that periodic classification of elements is based on the atomic numbers today, that is modern periodic table. So I am going to describe you about how these elements are classified into this periodic table. So there are some periodic trends over which they are classified. They are, firstly we are going to discuss about the atomic size. There are so many questions that tell us about potassium, magnesium, sulfur, iron, which of them has the largest atomic size. Okay, so I'm telling you how can you justify it, how can you find out the answer perfectly with giving the justification for that. Let us take a group. Remember this thing, there are 18 groups in a modern periodic table and 7 periods. Groups are the vertical columns whereas periods are the horizontal rows. So I am taking the first group, lithium, beryllium, boron, lithium, sodium, potassium, rubidium, cesium, francium. And this is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. This is a period, this is a group. You can see that these all have one thing common, that is the increasing order of atomic number. So as we are moving down the group, we can see that they have increasing order of atomic number. If atomic number increases, then it will already increase the number of electrons, because atomic number is just the number of electrons for a non-charged species. So number of electrons increase. If number of electrons increased, then number of shells will also increase. Listen, this is lithium whose atomic number is 3. So its electronic configuration is 2, 1. This is sodium which is of 11 atomic number. So it will become first shell comprised of 2, then is 8, then 1. Potassium and so on. So you can see that first element has 2 shells, then 3 shells, then shells keep increasing. That's why number of shells increasing. And now you can see if it has 2 shells, then the distance between nucleus and outermost shell is like this. Whereas if some element has 3 shells, then atomic number, then the distance between nucleus and valence shell increases obviously. So the distance between valence shell and nucleus increases. This distance weakens the nuclear force on the outermost shell. It weakens the grip of nucleus over the outermost shell. That's why nuclear force on valence electrons decreases. And in the same way, if nuclear force decreases, then because distance increases, then already atomic size automatically increases. If we observe it throughout the period, then we'll observe that this is 3, atomic number is 4, 5, 6, 7, 8, 9, 10. So configuration for this is 2, 1, this is 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. So what you observe that number of shells remains constant. We can observe that atomic number is increases slightly, but the number of shells remains constant. So the nuclear force force on valence shell increased over the shell effect, which will decrease the atomic size. I hope you get it. So, in both these situations, we can observe that along moving down a group, something which is increased, that will decrease when we moving from left to right in a period. So, if you have to check it out that potassium, among potassium, magnesium and sulfur, whose size is more and whose size is less, then what you have to do, you have to just clarify the situation of the position of them into the periodic table. You can see sulfur lies in 16th group, your magnesium is in 2nd group, your potassium is in 1st group. So if you observe them clearly, we know that on moving left to right, atomic size decreases. From moving top to bottom, atomic size increases. So in this way, 1st group has the largest size among all periodic numbers. So potassium has the largest size. Then between magnesium and sulfur, because atomic size decreases over a period, then we can say that magnesium has more size as compared to sulfur because it is far away than magnesium. Okay. So in this way, there are more periodic trends other than atomic size. Let us talk about the metallic characters. Metallic characters are those characters by which any element forms its compounds by the donation of electrons. That means it behaves like a metal. So, any element can donate its electrons only if its nuclear force on valence electrons is weak. So, if top to bottom nuclear force decreases and distance increases, so it is very easy to donate an electron. So metallic characters increases in moving top to bottom in a group, whereas decreases from left to right. Whatever you have studied about a group thoroughly, that will be reverse or opposite in a period. So if we talk about non-metallic are just opposite of them, metallic characters. Non-metallic characters are those in which an element accepts an electron. So they will decrease because these are increased. Electronegativity is the property by which any element can accept an electron. So it will only possible if nuclear force has the tight grip over the valence shell. So it will based on the nuclear force. So it will also variate according to nuclear force. So it decreases along the group, and it will increase along a period. It will decrease in a group and along a period it will increase. If we talk about ionization energy is the energy which is required for an element to remove an electron from its outermost shell. So an element, if the size is large, then it is easy to donate an electron, to remove an electron. So energy required to donate electron will be less. So it is also directly dependent on nuclear force. Okay, I hope you will understand all these periodic trends. It will help you. These all are helping you in your discussion or conceptual accountable question. Okay, so just remember by comparing and contrasting the factors. Rest of the topic we'll discuss in our next class. Thank you so much. Don't forget to subscribe my channel.